In physics, a force is said to do work when it acts on a body and there is a displacement from the point of application of the force. So work is when force causes a displacement. We measure work in joules because a Newton times a meter is the equivalent of a joule. So force is measured in newtons, displacement measured in meters. And just a reminder that a Newton is a kilogram meter per second squared, because a Newton is mass times acceleration. If we were doing this in non-scientific units, it would be measured in foot-pounds. You might have heard that term before, or kilowatt-hour. So to simplify this equation, a lot of times we'll write work equals force times distance times the angle between those two vectors. Remember, both force and displacement are vectors, therefore work is a vector. So we have a work is equal to the force vector multiplied by the displacement vector, and then multiplied by the cosine of the angle in between them. So let's talk about another way that we calculate work. So work is also the change in kinetic energy. So therefore it's the final kinetic energy minus the initial kinetic energy. And remember that KE, kinetic energy, is 1/2 mv squared. And that's measured in joules. So we can see how the change in kinetic energy is also equivalent to work, because work is also measured in joules. We also have the potential energy form of work, and that's minus the change in potential energy. So therefore it's minus the final minus the initial. And that's, remember, potential energy is equal to mass times gravity times height. And the reason work is negative in this situation is that it requires more work to raise an object, so to increase the initial, or to increase the final position, versus lower an object. Now let's talk about power and how that relates to work. Power is just the rate at which work changes, and that is work over time. So that's joules per second. And a lot of times we write power in things like horsepower or watts. So let's do a couple of example problems. First, we have a block on a surface, an applied force of 100 newtons, and the block's mass is 15 kilograms. And it says that a 100 Newton force is applied to move the 15 kilogram object a distance of 5 meters at a constant speed, and that's 5 meters to the right. So it goes 5 meters, it's displaced 5 meters. What is the work done on the object? So work is force times displacement times cosine theta, and our force is 100 newtons. Our displacement is 5 meters, and our theta is 0 degrees because they're in the same direction, so cosine of 0 is just 1. Therefore, our work is equal to 500 newtons in this instance. If we were to change the angle at which this force acts and say that it's pulling the object at an angle of 30 degrees, that's supposed to be 30 degrees, and that's still the same 100 Newton force, it still goes 5 meters in that same similar direction, our work will change because our angle changed. So remember, work is 100 newtons times 5 meters times cosine of 30 degrees. And that gives us 433 joules of work.